Hello students, today we are going to say class 10 max exercise 1.1 sum number 7. Let A equal to the set of all natural numbers less than 8, B equal to the set of all prime numbers less than 8, C equal to set of even prime number. We have to verify the following two subdivisions. First, natural numbers means it starts from 1 and it goes on. Set of all natural numbers less than 8 means we have to list all natural numbers that are smaller than 8. So the set A contains the elements 1, 2, 3, 4, 5, 6 and then 7. Next, the set B is set of all prime numbers less than 8. Prime numbers means numbers that are divisible by 1 and itself. So, the set of all prime numbers less than 8 means we have to list all prime numbers that are smaller than 8. So, the set B contains the elements 2, 3, 5 and then 7. Next, C. The set C is set of even prime number. 2 is the one and only one even prime number. So the set C contains only the element 2. Now let's prove the first subdivision. We have to verify that LHS equal to RHS. First let us consider the LHS. We should give first preference to the bracket. So let's find A intersection B. Just substitute the values of A and B. A intersection B means elements which are common in both A and B. The elements common in both A and B is 2, 3, 5, 7. So A intersection B is 2, 3, 5 and then 7. Now let's find A intersection B cross C. Substitute the values of A intersection B and C. Now let's find the cross product of these two sets. If we find the cross product, we get 2, 2, 3, 2, 5, 2 and then 7, 2. Now let's find the RHS. In RHS also first we give the first preference to the bracket. So now let's find A cross C. Substitute the values of A and C, then find the cross product. We get 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2 and then 7, 2. Now let's find B cross C. B cross C, just substitute the values of B and C and find the cross product. We get 2, 2, 3, 2, 5, 2 and then 7, 2. Now let's find A cross C intersection B cross C. Substitute the values of A cross C and B cross C and then find intersection. We have to find the elements which are common in both A cross C and B cross C. If we find the intersection, we get 2, 2, 3, 2, 5, 2 and then 7, 2. Therefore, LHS equal to RHS, thus we proved it. Now let's prove the second subdivision. A cross B minus A equal to A cross B minus A cross C. First let's find the LHS. We have to give the first preference to the bracket. So first let's find B minus C. Substitute the values of B and C. B minus C means elements which belongs to B but does not belong to C. Here the elements which belongs to B but does not belong to C is 3, 5 and then 7. Now let's find A cross B minus C. Substitute the values of A and the values of B minus C. If we find the cross product of these two sets, we get 1, 3, 1, 5, 1, 7, 2, 3, 2, 5, 2, 7, 3, 3, 3, 5, 3, 7, 4, 3, 4, 5, 4, 7, 5, 3, 5, 5, 5, 7, 6, 3, 6, 5, 6, 7, 7, 3, 7, 5 and then 7, 7. Now let's find RHS. First let's find A cross B. Substitute the values of A and B and then find cross product. We get 1, 2, 1, 3, 1, 5, 1, 7, 2, 2, 2, 3, 2, 5, 2, 7, 3, 2, 3, 3, 3, 5, 3, 7, 4, 2, 4, 3, 4, 5, 4, 7, 5, 2, 5, 3, 5, 5, 5, 7, 6, 2, 6, 3, 6, 5, 6, 7, 7, 2, 7, 3, 7, 5 and then 7, 7. Now let's find A cross C. Substitute the values of A and C and then find the cross product. We get 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2 and then 7, 2. Now let's find A cross B minus A cross C. Substitute the values of a cross b and then a cross c, then find the minus, which means elements which belongs to a cross b and the elements that does not belong to a cross c. That elements are 1, 3, 1, 5, 1, 7, 2, 3, 2, 5, 2, 7, 3, 3, 3, 5, 3, 7, 4, 3, 4, 5, 4, 7, 5, 3, 5, 5, 5, 7, 6, 3, 6, 5, 6, 7, 7, 3, 7, 5, and then 7, 7. Therefore, LHS equal to RHS, thus we proved.